we will talk about graphing rational function. And these are the few steps in order to graph a rational function. There will be a few more, but this will be the first few steps. So first, any rational function, we need to know what is the domain. The domain is whatever the denominator not equal to 0, because we cannot divide by 0. So we write the denominator not equal to 0. So x squared not equal to 4, and so x squared, we will take the square root on both sides. So the domain is x not equal to -2 and x not equal to 2. Just going to write here. That is the domain. Now we go to the vertical asymptote. The vertical asymptote is not part of the graph, and actually that will be where the function is undefined, so somehow related to this. So for the vertical asymptote, what we do is we let the denominator equal to 0, make sure that the top is not. So I will write which is x squared minus 4 equal to 0. And pretty much exactly like what we just did, we have x equal to 2 and x equal to -2. Right. So that's what we have. We do need to make sure that when x equal to 2, put it in this function that is not equal to 0, and x equal to -2, and put that function that is not equal to 0. So we say when x equal to 2, we put 2 in the top. And if we do that, we have 2 squared minus 2 minus 12. That's not equal to 0, which is good. So we have one vertical asymptote. Next, we do the same thing. Put -2 into that function, on the top, the numerator. So we have -2 squared minus -2 minus 12. That's not going to be equal to 0 either. So we have 2 vertical asymptotes, x equal to 2 and x equal to -2. I'm going ahead and just put that on the graph here. So that is one vertical asymptote, and this is the other. Remember, that is not part of the graph, but that's what we have. We need the asymptotes to see what the graph will look like. Right, next, the horizontal asymptotes. This will done completely differently. We will base on the degree on the top, degree at the bottom. If you look somewhere online, there will be like acronym something like this. So it says bigger on the bottom, y equal to 0 is the horizontal asymptote. Bigger on the top, there will be nothing. Exponents are the same. We divide the coefficient. So in our case, we have degree on the top is 2. And both of them are the same. Therefore, we have this case. the horizontal asymptote will be the ratio of the coefficient. So we take the x squared divided by x squared pretty much. The coefficient here is 1 and 1. Just say it. We can write 1 over 1, which is equal to 1. And that is the horizontal asymptote I'm going to put on the graph. Right. So that's the first few parts of the problem. Next, I'm going to erase that's what we have at the moment, and we'll add more features on the graph, and we can graph. Recall we have the horizontal asymptote at x equal to 1, 2 vertical asymptotes. Now we find the x-intercepts and the y-intercept. Notice potentially we may have more than one x-intercept, but y-intercept we can only have one. Right. So for the x-intercept, we let y equal to 0, and then we solve for x. Y is the function f of x, so we have that equal to 0. And the rational function, it is equal to 0 when the top is 0, so we only have this part equal to 0. And we don't have much space here, so I just have to solve by factoring. So we have x equal to 4 and x equal to -3. So the x-intercept we have equal to 4 and -3, so we should write as a point or just x, it doesn't really matter. X is 4, y 0, and x is -3, y 0. So we have 2 points, 4 and -3. So that is x-intercept, we let y equal to 0. To find y-intercept, we let x equal to 0. And we find y. So we will put 0 in for x, and we have y equal to the function when x equal to 0. So put 0 here and 0 here, we will have so over from 0, we have -12 over -4, and that is 3. So we have x equal to 0, y equal to 3. Right. So that's pretty much some of the characteristics of the graph. To make it easier to graph, I'm going to do one more part, that is this. Does the graph cross the horizontal asymptote? Notice that if we have a point here, it cannot cross the vertical asymptote because it could not be a function. It can cross the horizontal asymptote. So we have to check to make sure we have that or not. The graph will cross the horizontal asymptote where this function equal to the horizontal asymptote, that is x equal to 1. So we just need to make sure, y equal to 1. So we let y equal to 1 equal to the function. I'll multiply x squared minus 4 on both sides. Right. Both of them have x squared, so can cancel that on both sides, or minus x squared on both sides. And then add x to this side, then plus 4. So I will have x to this side equal to negative 8. So when y equal to 1, x is negative 8, there's a point on the graph, so actually we have to worry about this point here. So that's all the point we have. Right. Now let's just summarize everything. This is what we have. 2 vertical asymptotes, 1 horizontal asymptotes. Those are the few points. And we don't know that the graph only crosses the horizontal asymptote at negative 8. So let's say from this point, it will not go across the vertical asymptote. So we have to go like this. And it can only go close to the horizontal asymptote. It cannot cross it. It only crosses here. So it will be like this, part of the graph. Next, in the middle, we know that from this point, it will not cross the horizontal asymptote. It only crosses here. So we have one point. It's difficult to tell if this is the lowest point or not. But it cannot go below this line. So it will have to go like that. We do not know if this is the lowest point, but it will have to go across the vertical asymptote on that side. It cannot get below this line. Right. Next, the graph will approach to the vertical asymptote here. It will go up and hit that point because we show that x equal to negative 8, y equal to 1. So we have that point. Yeah. So that, and after that, it will go briefly for a moment, but then at the same time, it has to go back to approach the horizontal asymptote. So the graph will not go to infinity. It can only go closer to 1 because the horizontal asymptote earlier we found that it is 1. So it will go past that point, get a little bit above the horizontal asymptote, then get back down and approach the horizontal asymptote. So that's what the graph of this function look like. It will go through a lot of steps, but when we go put all together, we have this graph. Note that the vertical asymptotes are not part of the graph. So the graph actually is just the one in green here. And that's the graph of the function. I hope you found this video helpful. Thanks for watching.